Okay. So again, last meeting, we have discussed about this formula, the flexural stress or the bending stress on beam. Okay, take note how when a beam is subjected to an external load or externally applied load, okay, so it tendency beam, of course, to react at its support. Okay, ang reaction din ng supports, tawag ito na iya is external reaction. Okay, external reaction because the reaction can be found on the external part of the beam and to it guwasit beam. Now, it nahitatabo gihap when you subject a beam on a force or externally applied force, the beam is subjected into, then of course it at mga grain or mga fiber na nagme-make up ito nga beam will also be reacting to what has been applied to it. Okay? Amo na ito niya nga may natin sinisira nga flexural stress or the flexural bending stress. Amo nito niya itong mga kumbaga we consider it also as reaction pero itawag ito na iya is internal reaction because it happens dito hit pinakasuludit beam. Okay? Dito hit suludit beam. Okay, so reaction ito niya because of the externally applied load. Now, aside from the bending stress, let me open another topic. But before, I mean, later, may natin di-discuss later hindi ma'am. Okay. Explain ko lang na kung ano pa nga type of stress it na experience it beam when it is applied to an externally applied load or internal reaction. Itatang di-discuss yan. Because anyway, pag biling hit external reaction, masahin man lang. Diba? Okay, another stress that we can expect the beam to and maging reaction hand beam internally is what we call the horizontal stress. Okay? So we call it the horizontal shearing stress. Ano ba ibig sabihin nito? Okay, let me stop my presentation lang. Focus na ni ka mo diha akon. Okay, if you can still remember, akong gin-example ha iyo last meeting is ang libro nga ni, di ba? Nandun pa kami, handbook. Okay. Nandun pa kami handbook nga ni, di ba? When the book is subjected to a load like this, parang magbe-bend hiya, di ba? But if you glue, one iglue, what na ito pa? Yung nga niigluan mga sheets hini nga paper or hini nga book. Okay, parang medyo in a way ako rin na iya ma-bend, di ba? Because now if you glue the sheets together, parang an sheets, dili na hiya free to slide on each other because of the glue nga naghihinder para mag-slide hera. Di ba? That's why kung imo nga ni in-glue, medyo makukurean na itong hiya ka-bend. Okay? Now, because of the bend, I mean, because of the force subject applied to the beam, ba tendency pasugan. Okay. So in a way, an imo sheets, ba as I have explained, nagkukuan hiya parang nag-wrap on each other, di ba? But because of the glue, okay, which is actually the case with the heat beam, kay diri man talaga ito niya mga sheets, but when we consider it as it nga, but if we consider it as a sheet nga gin glue together, okay, and glue ang naghihinder para magkuan, mag-slide hira on each other. Now, diri naman hira nakaka-slide ano. So the force instead nga magkuan hira tawag ni mag-slide. Okay, ano nga stress it na form? 'Di ba? Kita daw it movement. 'Di ba pasugad-sugad supposedly ira pag-slide. Because of the glue, parang the force and the area are parallel to each other. So nakakamay na kita yung sinisiring horizontal shearing stress. So any two sheets, pananglitan may dani mo two sheets dinhi, hindi dinhi nga papel. May da two sheets. Dili naman hira free to slide on each other. Ito nga two sheets, parang nagkakamay ada hirahin stress. Kay kumbaga diri naman hira free to slide. So it nananabo, kung diri hira free to move, nagkakamay ada stress. Okay, since the force and the area are parallel, di ba? Nagra-rub man. Okay, are parallel. They are parallel. The force and the area are parallel. So it na form nga stress is what we call the horizontal shearing stress. Amin hiyad ang kanina nga wala ko pa nga i-present ang formula ano. Okay? So amo ito ni sinisiring nga horizontal shearing stress. This is this. Okay? Horizontal shearing stress. Okay, now how do we solve? How can we express this in terms of an equation? The horizontal shearing stress. Okay, the horizontal shearing stress is denoted by FV. Okay, we are using V to indicate shear. Horizontal shearing stress man, di ba? Horizontal shearing stress is equal to ano ba yun? Q V over I V. Kaya FV is equal to QV over IV. Are you familiar with this formula? Who's familiar with this formula? Anyone? Anyone? Waray ba familiar ha iyo ini nga formula? Okay, so I guess hindi pa naturo. Okay, so this formula is the formula used to solve for the horizontal shearing stress. Okay, where your Q, later explain ko it Q. Let us explain lang na yan iba. And V. Ano ito nga V? And V, amo ito niya ang shearing force at the section of the beam. Okay, balik kita nga didihan aton previous nga kuan. Topic. Okay, didi. And di ba din, hey, this is the load diagram, this is the shear diagram, and this is the moment diagram. So kung parang kita, this is the load diagram, di ba may nadida niya reaction. So if imo shear diagram, nasugad dito. Masugad, tapos sugad. Di ba kasi ito na shear diagram? Amoy ni shear diagram. Okay. So ano ito itsura shear diagram? Okay. So ito nga shear and V kangina, diba? QV over IV and V and shear force or the V, the shear. The shear force at a certain section, kung hain man nga section ang iyo kukuan ko consider. Okay, so meron nga ni nga at the section 2 meters from the left support. So ani din to somewhere here din nga section 2 meters from the left support, di ba? 2 meters from the left support. Okay. Now, question. Based on this figure, kita niyo height figure, let us erase this one para hindi ka mo confuse. Edit shear diagram ha. Nakikita niyo? Nakikita ba? This is the shear diagram.
Yes, sir.
Okay. So this is the shear diagram. If you are designing the beam, di ba? Kaya kang kita. Okay. Before kita ipakiana, let me ask you a question again. Kung nagdi-design kita, let's say for example a beam, ano it aton din ko consider? Ano nga section it aton din ko consider when we are designing the beam? Okay? Or more specific, when we are designing the beam based on the bending moment, ano nga section it aton din ko consider? Ano nga section it aton pagbabasihan it aton design? Anyone? Let me ask you a question lang. Parang a recall lang or a recap lang hanaton last meeting, hanaton topic last meeting. Okay, so the question is, if you are designing the beam, so nagdi-design ka nga ng beam, designing a beam based on the bending stress, okay? Based on the bending stress. Ano ang imo pagbabasihan na section? Which section will you base your design? Okay, hayan nga section it imo i-consider when you are designing the beam due to flexural stress. Okay? Anyone? Anyone?
4 is the smallest planet. So 4 is the
Maurice. Okay.
is 2.
An part po sir han beam na most likely to fail if gin-applyan na in force.
Mhm. And what section is that? How do you describe that section?
5 extra 4.
Amo na ada sir takdibat
The section. What do you call that section, Mr. Kant Dumas?
Most vulnerable section, sir.
The
Most vulnerable section.
the most vulnerable section. Okay, let me go back to my question, ma'am. Okay, nayakang kita, when we are designing the beam, due to the moment or the bending moment, we base our design on the most vulnerable section. And that is usually the section where your beam will most likely fail, di ba? Because that's the most vulnerable section. Kaya ano gimbi-base natin dito ang most vulnerable section? Because nayakan, your structure daw is as strong as its weakest link. So you have to find the most vulnerable section. You have to find the most weakest section for you to be able to uh, design your beam properly. So kumbaga gina-anticipate ni mo it mode of failure. So kung if your beam will fail due to moment, dito kikitaon nimo kung na it most vulnerable section due to moment, bending moment, di ba? May dagat kita, most vulnerable section due to shear. Now, look at this diagram, this shear diagram. Where do you think is the most vulnerable section? Kita daw niyo. Where do you think is the most vulnerable section? Due to shear. Anyone? Open. Okay. Anyone? Iba naman, pero nalahi Maurice. Any volunteer? Maniakas, yes. Mr. Maniakas.
And center part po, sir. Center part.
Center part, why? Mr. Maniakas. Why midpoint? Bakit midpoint than most vulnerable section due to shear?
Amo la sir mo ray support, sir.
Okay, ambulance support. But when you look at the diagram, Mr. Maniaca, look at the diagram. Where can you find? Okay, let me go back to the equation. Perhaps we have to look at the equation. Okay, now F ano ba yan? If Q, if this okay, if QIB is constant, di ba? If QIB is constant, okay, yung V mo, when V goes up, your FV will also goes up. This is the stress, horizontal shearing stress will go up or will increase if the value of the shear increases. Okay, balik kita nga din. Ano ng shear diagram. Look at the shear diagram. Ay na. Okay, adi ha. This is your shear diagram. Where do you think, what section an high section and mas dako and horizontal shearing stress? In which section do you think the maximum horizontal shearing stress is can be found? Can be found. Mr. Maniaka. Anybody?
Sir, on both ends po, sir.
Why, Mr. Maniaka? Kay ano daw la, Mr. Maniaka, mga both and
Nag-base la po akan ano, sir. Shearing diagram po.
yes. What can you find in the shear diagram? Why did you say nga ato didtohan support at the kuan at the end part? Kaya ano ato at the end part? Kaya ano diri di dahit but nga? Why? Please observe the diagram. You are basing your answer. You're claiming that you are basing your answer on the diagram. Please look at the diagram. Kaya ano ato hit support it most vulnerable section with respect to the ano to the shearing stress. Why do you think so?
Kasi po, sir, ang support po, ang beam po ang nagsusupport ang whole weight. Load po.
Dili ka ada na yakap. Wait lang ha. Ikaw mo ha, nagdi-discuss nga ni ako, nagyayakan nga ni ako didi. Please try to understand what I am talking here. Okay? So when I ask a question, dapat
Sir, sorry po,
Never
sir. Wala
mind.
po kasi ako kakulop, sir. Ton Sunday po. Sorry po.
Never mind. Okay, let me call another one.
Try to refactor that one.
83. So 83. Any volunteer? Gusto ko iba naman nga tao. Adi, Paulo Piñaranda. Paulo. Paulo? Oh. Gin-open line na naman ito tapos di nga yan namamati. Ada ba Paulo or nakaturog kay Paulo? Hello?
Always remember
Any volunteer? Bakit?
the factors. Binomials.
Parang kamo kun diri nga ni kamo kung sugod nga ni hinit iyo ko anit discussion parang nakukuha na ko it discussion yun diri wala nagpo-participate. Okay, mapay nalakay may duduha ka tawo tutulong nga nagkukuha nagsinaliwan-saliwan hit pag-a-answer. Please, I need your cooperation para mapait aton discussion. Try to understand because every now and then I will ask questions so diri ka nga ni namamati diri ka talaga makaka-answer. Okay? Okay, Mr. Dumas.
Nga da may answer kaya tumanan support. So kung may load nga may parallel nga load ha support bagat magsi-share ngadto. Mas dakot share. Since nga tuman reaction.
Okay, you have an idea pero look at the diagram. Look at the diagram. Di ba nayakan kita? Okay, balik kita ha. Balik kita nga dyan ako an explanation. Okay, basically parang I am handing you the answer na. But I want to hear it from you. Okay, this is your formula for the horizontal shearing stress. Now, if Q, I, and B are constant, so ibig sabihin dahil nag-change, constant here. Now, as you can see, the horizontal shearing stress is directly proportional to the shearing force, to the shear force. Di ba? Kita daw niyo. So, they are directly proportional, yung FV at saka yung V. Okay? Since they are directly proportional, ibig sabihin, if V goes up, yung value ng FV mo will also increase. Diba? It will also increase. Kung mag-increase ang imo V, ma-increase gapan imo FV. Okay? Okay. Dili kita ha, balik kita dili. Nayakan ka mo nga most vulnerable section of simply supported beam in terms, due to shearing failure or due to the shearing failure, the most vulnerable section is at the support. Okay? Why? That's what I am asking. Kay ano nga ada di dahit support? We're talking here, kuan ha, simply supported beam. Okay. That's correct, added support. But I'm asking you, kay ano daw lang added support? Pwede man aani din hit center. Pwede man aani din hit kuan. Now, on this case, aada daw with support. Why?
Actually, there's a lot of way in making a graphical
Kaya mo't dapat
Yes.
evaluate V, sir.
And
Who was that? Sino adto? Mr. Miss Hermoso.
something public declaration na
Miss Hermoso.
Sir, ito expected nga external force kay paubos
Basta kay itong reaction nga man higugma man. So bagat nagclash itong forces. So bagat ma-create in shear nga. Shear stress.
How about the English? You already submit the.
So what's your answer to the question? Kay ano nga ato dito hituan, ato hit kay an support ti pabaw-baw? Is that what you
Kay may opposite nga force nga na-react man. So bagat nagko-cause clash ba ito nga part
Ano naman
yung two forces.
Saturday. Press lang Saturday.
not why? Because how about Miss Hermoso? Equation is this one. Nasugad. This is the reaction. Other than support, sugad. Tapos nasugad. Other the NP. Okay. So where do you think is the most vulnerable section?
Okay, so
Okay. Okay, let me rephrase the question. Okay, in general ha, there in this situation because in this situation kasi the force, the load diagram is uniformly distributed all throughout the span. Okay, for in general situation, where can you find what section is the most vulnerable section in terms of shear failure, horizontal shear failure? Ano nga section? Anyone?
Third section nga nakaka-receive yung pinakadako na shear force.
Who's talking? Kanina ka pa.
Roquero, sir.
Roquero. Okay, Mr. Roquero. So, can you repeat your answer? Why do you think, where do you think is the most vulnerable section with respect to shear failure,
Ano section, sir,
horizontal shear?
Sir, ang section nga nakaka-receive ang pinaka akong shear force.
Very good. Okay. So the section where the section with the maximum shearing stress, sorry, shear force, the maximum shear force is the most vulnerable section in terms of shear failure. Okay? Amo iton. That's why if you draw the shear diagram of this load diagram of this type of load of this type of beam, simply supported beam with subjected to a uniformly distributed load, so it so right stress it shear diagram nasugad ito niya. Amo it itsura. Nakikita niyo it itsura niya. Let me erase this one. Dili ka mo ma. Amo niya itsura ini. Okay? Now, as you can see, it marks 0 at the center, not the center, 0 at the midspan, and I'm talking about the shear force, 0 at the midspan, maximum at the supports. Okay? Maximum at the support. Okay. So, ibig sabihin, one of the most vulnerable section is the section at the support because vulnerable here in terms of shear failure. The section on the support may not be vulnerable due to the bending moment. Let me draw the bending moment again para makita ni. Di ba na ano ato an itsurahan kuan han bending moment, di ba nasugad? Maximum at the not the centroid, the midspan. Adi din pinaka-maximum value. Okay? Baga may project nasugad dito. Yan. Okay. So, as you can see, okay, in terms of shear failure, the most vulnerable section is the section at the supports. Here, di ba? Din here. Okay. Now, in terms of the bending moment or flexural failure, tawag ita iya. The most vulnerable section is the section at the midspan. So, duduhait imo vulnerable section. Okay? the section most vulnerable to shear failure and the section most vulnerable to moment or to bending failure or bending flexural failure. So duduha ito niya. Okay? So duduha ito atong pupulawan. Now, this is also the reason, sagway lang kita ha, this is also the reason kung makita ka mo dahil ko, makita ka mo actual practice. Diba? Kung baga, if this is your, if this is your beam, diba? Nasa ulit atong beam. Dito atong beam, kung aarit bot nga it bar, diba may namit bar, itiret bot nga it bar, mas damo itong didait mga reinforcement. Okay, mas damo ito ng reinforcement. Tapos pagkadiliha ligid, medyo 2 pairs na lang ito nandito. Parang nasuga dito.
Last one first. Then after that one, I'm going to check first before we continue.
Let me
Practice lang. I know you already know this one.
let me draw.
Just following kasi the sequence.
So dito.
Sequence topics, which is this topics is from the data naman, so that's why I don't answer this one already.
Para nasa palit it. So, okay. So, as you can see, mas damo it main reinforcement dili haubos. Because again, kaya ano adi haubos it main reinforcement kaya add to it tension because your concrete is most vulnerable. I mean, it has a very high compressive strength but very low tensile strength. That's why it more reinforcement at to haubos. Tas mas damo dida it reinforcement didi haubos at the midspan because nga of the fact that the most vulnerable section due to bending is at the midspan. Amo ito nga mas damay iya main reinforcement. Okay? Pero in terms of horizontal reinforcement naman, ano itong horizontal reinforcement? Okay. Nakakakuha kami siya ka man inig ka-drawing. Di ba nasuga dito? That's your beam, pananglitan.
Is the deadline about today? Is the deadline?
Okay, tapos meron yung beam. Nasugat. Okay. Tapos, di ba may dito mga hook, parang nasugad? Nakakakuha ang kamay ito. Hindi nasugad. Hello,
Mga concerts kayo.
nakakakita kami. Ang mga stirrups
Yes,
yan.
sir.
Stirrups,
Yes, sir.
tawag ito. If nakakita na kamuha construction, it's stirrup, mas so ito niya, kung aad hiranit support. I'm talking about the beam ha. It's stirrup, mas so kung mas haran niya support. Because again, because of the fact nga mas vulnerable in terms of shearing stress, mas vulnerable ang section nga hirani di dan support. Diba? Adaman, mas dakot iya shear force. Diba? The force here are parallel. I mean, the force here, the direction of the force here is along the y-axis. Parang, diba? The direction of the force is along the y-axis. Thus, as you can see, the direction of the bars here and reinforcement din is along the y-axis also. So kumbaga hira ito ang nagko-compensate I mean, mas damo dida ang reinforcement, okay, and stirrup para mas ma-carry niya ito nga mga forces. Okay, mas damo man dida. Okay? Mas pagkadidabot nga minimal na la ito ni reinforcement kasi mas guti man dida it kuan, mas guti man dida it not the stress. Oh yes, the stress. Mas guti stress because mas guti it shear force. Diba? So, it aton reinforcement, nagva-vary it iya number of bars, it iya number of reinforcement, na depende hit aton gina-anticipate na shear stress. Okay, it aton shear stress naman nakadependehan shear force. Diba? So, kung hain mas maximum ang shear force, ato dito ang maximum ang shear stress. Mas damo ang reinforcement dito. Diba? That's why, as I have said, nagde-design nga ni kita, pero may itong gina-anticipate it mode of failure. Okay. Makikita mo, maximum it moment dili midspan. I have to prevent that. How do you prevent that? More reinforcement at the midspan. Okay, okay na for moment for failure due to moment. Takay diri man laan failure due to moment itim kikitaan. May dapat kita failure due to shear force. Diba? O kikitaan mo, kind body in most likely mag-fail due to shear force or due to shearing failure and aton beam. Kitaan yung punhain din ang maximum stress. Ang maximum stress, dito ito makikita ang punhain ang maximum shear force. And it so happen nga that dida heat support, di ba? How do you how do you intervene? What is your engineering intervention for that case? Naghahatag kahin more reinforcement. Okay? Para ma-prevent ang failure due to shear force didtuhan reinforce didtuhan support hanaton beam. Okay? So amo liton magdi-design ka nga ni anticipate the mode of failure. Okay? So that's it. Okay. So ibig sabihin your V here is just the force, the shear force on the section of the beam, on the section where you want to get the stress due to the horizontal shearing the horizontal shearing stress due to the shear force. Okay? Ito niya V din here. Okay. Now, what is the value? Ano niya nga I? Ano niya nga I? Ini nga I, di ba? Para na makamuhan I is the moment of inertia. I is the moment of inertia. Yung assignment ito. So, if you are given with a rectangular beam, masayon let pagbiling hit I. Take note, ini nga I, ini nga mga formula, pati anya ding I, didi, ini. Okay. Ito nga mga I, and I ito niya, of the section, the eye of the section with respect to its neutral axis. Kaya ito nga mga eye is the eye with respect to the neutral axis, and we all know naman that the neutral axis is the axis that passes through the centroid of the section. Okay? Yun. Okay, how about the B? Ano ito yung B? The B is simply the width of the fiber you are considering. Okay? So mara naman kamo kung ano ng mga fiber, di ba? Pananglitan, this is the neutral axis. Pananglitan adi nga fiber ani mo ko consider. What fiber? The fiber which is sigunta nga 100 mm from the neutral axis. So pananglitan, this is 190 and this is also 190. Okay. So, pananglitan adi nga fiber na natin ging ko consider. So, ibig sabihin, find the shearing stress on the fiber 100 meter from the neutral axis. O, dito nga fiber. So, ano tayong babaluit B dida? B is the width of the fiber. Ano it width ng fiber? So, pananglitan, if this is, say, 150, pananglitan, 150 mm. Okay, so obviously, unwidth fiber is the width of the section, and that is 150. So amo ito na B, the width of the fiber. Just be careful because kung rectangular, masayon lang pagbiling. How about if the section is a T-beam? May nakita sinisiring kasi nga T-beam. Okay? How about kung T-beam niya? Kung pananglitan, adi nga fiber team ko consider, o amo lang niya nga width, inila nga distance, it imo ibahatag, didahan valuehan B. Okay? Pero kung nan imo yung consider nga fiber, an adi didihan niya, tawag ito, flange, niya flange, pananglitan if this fiber an imo yung consider, ini nga distance, ini nga width, an imo gagamiton. Amit yung ibubutang didahan B. Okay? So, in other words, B is the width of the fiber you are considering. So, kung hayan mga fiber it will consider. Okay? Now, how about Q? Ano ito nga Q? Masahin lang pagkuhan ni Q. Q is the moment area of the area above or below the fiber you are considering with respect to the neutral axis. So, parang parang halaba man, parang medyo malipong. Okay, let me say it again. Q is the moment, area moment, kaya area moment hiya. O sa area moment man, ano nga area? Area nga above, what's the above of the kuan? What area is the above of the fiber? Di ba this area? Okay. Q daw is the moment area of the area above or below. Take note ha, or below the fiber you are considering about or with respect to the neutral axis, with respect to this axis. Okay, so pananglitan, this is the area. Ang moment area man natin bibiling, di ba? Nayakan daw, Q is the moment area. So bibiling ko nimo ang centroid dito nga area and the distance of the centroid of the area to the neutral axis. Di ba? Pera ba ito niya? So if this is pera niya 90, di ba? 90. So ang katunga 45 plus 100. So this distance is 145. Do you agree? Do you agree?
Yes, sir.
That distance is equal to 145, right? Okay. So kay 145 man, Q ang natin bibil nga no? Q is equal to the moment area. How do you solve for the moment area? How do you solve for the moment? Moment is equal to force times the perpendicular distance of the force from the reference point, di ba? So kay moment area man or area moment man ang bibiling. So an area, what's the area? That is 90 times 150. That's the area, right? That's the area, the shaded area. Times the moment arm. Kay moment area man ang bibiling. Moment arm, of course, from the centroid to the axis where you are getting the moment area. The axis where you are getting the moment area is the neutral axis. That distance is equal to 145. So this is 145. Pera ba in here? 90 times 150 times 145. Times 90 times 150 times 145. That is equal to 190. 1,957,957,500. Is it right? Or mali ako? Asya na.
Sir.
Amo na, sir.
1,957,500. Okay, this is in raised to 3. Okay? So Q, ito niya Q. Again ha, let me say it again. Q is the moment area or the area moment of the area above or below the fiber you are considering with respect to the neutral axis. Okay, now let me direct your attention to the definition. Nayakan dito above or below daw. Q is the moment area of the area above or below the 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 fiber you are considering. Above or below daw. Hindbite area below the fiber you are considering. This is the fiber you are considering, right? Let me erase this para makita niyo. This is the fiber ang ating i-consider. The area below that fiber is this one, right? Take note, adi dili ubusan neutral axis. Member lagyap itong hiyahan. Area below the fiber you are considering. If we get the moment area of that area about the neutral axis, of course, that would be equal to, pero in here distance, that is 190 plus 100, that is 290. Diba 290? Kaya tikan din nga di 190, tapos tikan din nga to 100, 290 times 150. What's the moment arm? Hindi in it iya centroid, di ba din eh? What's the distance of the centroid nga dilihan? Ada dida. What's that distance? That is 290 minus 290 over 2, right? Ini tikan din
Yes,
nga
sir.
to dito. That is 290 over 2. Tapos tikan din from the neutral axis nga to dito fiber, that is 100. So minus 100. Okay? So ini nga distance, ini nga distance, this distance right here is equal to this distance minus 100. And we all know naman that this distance is just half of this distance, di ba? Saka ini that is 290, half man daw, 290 over 2 minus 100. That's why ini nga distance, di kan din hit neutral axis nga dahil din nga centroid of the area below the fiber you are considering is this quantity right here. Okay, so this is equal to pera. I'm very sure this is equal to 1,157,500. This is in raised to 3. Okay. That's why in the definition, nayakan, Q is the area moment of the area above or below the fiber you are considering about the neutral axis. So, for simplicity, of course, para madagmit it imo pag-solve, na-prove naman nato nga equal la itong hera. Yung nag-solve dito ito imo solution, mag-iiniha ka pa. Bibiling niyo mo yung Q, it pili ang nga area, it masayon. Hain ba it masayon nga area? About the neutral axis man it imo kukuha nga moment area. Wa yung area it gamita, di ba? Kaya masayon. Get the centroid, get the center of the the distance from the center of the area to the neutral axis. Makukuha ni 1Q, di ba? Kasayon la. Now, how about if the fiber you are considering is below the neutral axis? Haing nga area team kukuhaon. If that is the case, haing nga area team kukuhaon. Of course, obviously, let me erase this one. Okay, obviously, it kuha nga area. Yeah, di. Nga area. Diba? Ayaw pagkuhaan niya di nga area. Kay kukurean ka. Diri ka na tuod, okay lagi hap. Walang basagan ng trip. Diba? Okay, basta. It value ito nera, hit Q. Equal lagi hap ito niya. Okay? So, that's it. Okay, so you have here the formula for the FB that is equal to QV over IB. Okay? QV over IB. Q is the area moment. V is the shear force on that section. Your I is the, ano to I? Moment sorry.
Inertia.
Term, inertia. Yes, moment of inertia. B is the width of the fiber. Okay, so amo ito niya. Okay, let us draw the let us draw the diagram, the stress diagram, because we need to understand kasi what is happening internally. Kasi aton panuyuan yan na, di ba? Internal reaction. Let me erase this. Oh, what's happening? Nag-froze. Daming langaw. Okay. Okay, balik lang kita didihan ko ha. I think in drawing ko ato ani stress diagram. Adaman, di ba drawing ko ang stress diagram? This is the stress diagram. I mean, here, this one. This is the stress diagram for the, ano tawag niya? The flexural stress or the bending stress. Okay? So, compression at the top, tension at the bottom. Okay, pero danay damat, tension at the top, compression at the bottom. Depende kung ano nga type of beam. Okay? Take note, we have a beam, a cantilever beam. Diba na sweat cantilever beam. Okay, pananglitan na didian forces, didian forces. So, it iya pag-bend, masugad. Di ba? Masugad it iya pag-bend. So, adi haubos, and nakukompress. Ato habaw-baw, and natitense. So, for this kind of beam, it tension, ato habaw-baw, it compression, and haubos. So, this is not always the case. Okay? Pero, always ito niya nga, tension and compression on the opposite ends of the fiber. Okay? Tapos, 0 at the neutral axis. Okay, so this is the stress diagram for the flexural bending stress. You know, what is the stress diagram for the horizontal shearing stress? Okay, project natin. So, good. Project natin an ano yan. Okay, iat itsura. Okay. Take note ha. Okay. Diba, an imo Q, kita daw, an imo Q is a function. Okay. Balik kita din nga formula. On a certain section, pananglitan, on this section lang yung I mo is constant. Because the I of this point right here is equal to the I of this point right here. Or should I say, ito nga point. The I of the fiber here is equal to the I of the fiber here. Diri nakamute. Diri nakamute. Kaliba. Okay. So the I of the fiber here is equal to the I of the fiber here. Diba? So ibig sabihin, what I'm trying to point out is yung I mo for this whole section is constant. Okay, so constant it I. It imo B, since this is just a rectangular beam, your B is also constant. Diba? B is also constant. Your V, your shear force on this section is also constant. Okay? Nagva-vary V from section to section. Pero kung ada kit single section, it iya ito and be constant all throughout the fiber. Okay? It nagva-vary la it Q because it imo Q na depende kung hay nga fiber tingin ko consider. Okay? And take note, your Q is a function of, since yung B is constant, that is just a function of its horizontal distance from the neutral axis. No, vertical distance, I mean. The Q is a function of the vertical distance from the neutral axis. Okay? By how much? I mean, but in what way? Okay. Take note, in what way? Ibig sabihin, is it linear or is it quadratic? Diba? The answer is quadratic because as you can see, moment area man, diba? So, duduha nga movement area, duduha nga quantity and about the y-axis. Okay? So, kita daw, pananglitan if this is the fiber. Tapos ini nga area ni yung consider. Duduhaan iya along the y, this distance, and its distance from the neutral axis. So duduha. So ibig sabihin quadratic hiya in terms of its distance from the of its distance from the neutral axis. Okay. So ibig sabihin it imo FV is a function ultimately your FV is a function of its distance from the neutral axis, quadratic. So kung quadratic hiya, it sura na so good. Okay, so this is the stress diagram. Take note zero hiya kita What is the value of Q? Dili kita dili. Balik ta magsasama kasi dito kon ito nato ning butang. This is the neutral axis. Ang pananglitan ading fiber naton ging ko consider. Okay. What is the Q on that fiber? So obviously, wala nimo makukuha nga area above, di ba? Pero may the area below. Gamit tayo area below this area. So, this distance times this distance, di ba? Times the distance of the centroid of this area from the neutral axis. Since this is your neutral axis, di ba? An imo neutral axis nga nan iya centroid mismo adahan neutral axis. So ibig sabihin wala niya moment arm. So an imo valuehan Q is 0 if you are considering the outermost fiber. Okay? If you are considering the outermost fiber, the value of Q is 0, and that means your FV is also 0. So ibig sabihin, if we draw the stress diagram here, the horizontal shearing stress diagram, 0 iton at the external fiber, ang pinaka outermost fiber. Tapos, maximum hiya, the stress is maximum kung aada ang fiber han neutral axis. Okay? Kung ang fiber nga aada han neutral axis ang imong ko consider, maximum ito imo horizontal shearing stress. So maximum. So somewhere here. So kung nato ito drawing on it sura na sugad. Curve hiya. Take note curve. Diri hiya straight line because again quadratic it iya behavior it graph. Okay? Quadratic. So gadin it sura. Quadratic. The degree of this curve is 2. This is actually parabola. The degree is 2, 0 at its end dito han outermost fiber outermost fibers, the outermost fiber in compression and the outermost fiber in tension, both are 0 in terms of the horizontal shearing stress. Yan. And the degree of the curve is 2. And of course, the maximum horizontal shearing stress is at the neutral axis, the fiber on the neutral axis. So amo iton hiyat maximum horizontal shearing stress. Okay? So nag-iiba herahit ko ano nag-iiba herahit didihit flexural bending stress. Kaya flexural bending stress, maximum hiyahan outermost fiber pero zero at the neutral axis. Nakikita niyo it scenario. Parang they are in a way opposite to each other, di ba? Maximum and moment didi, zero and shear dida. Pero pagka didi, maximum and shear, zero and moment. Diba? In terms of the stress diagram. Okay, so amo iton hiya ha. Okay. So kadito, it aton concern niya na 6:10. Still have 2 hours. 2 hours left pa. Okay, so dako pa aton oras. Okay, so it aton concern niya na pag-compute hiton nga mga stresses because according to our and aton didihan aton syllabus, if you have seen the syllabus kung unit na download as ginbasa chapter 2, the analysis of external reaction and internal stresses resultant. Kaya resultant daw. So internal stresses, ito nga mga flexural shearing stress, ito flexural bending stress, tapos ito nga horizontal shearing stress. Ito mga internal stresses ito. Kaya ano may kita sinisiri nga internal stresses resultant? Ano ba ibig sabihin ito? Okay. Dili kita ito nga ano ba sinisiri ito nga mga resultant. Dili kita ito sample problem. Para makita niyo kung ano may resultant, let's try a sample problem. Pananglitan. Okay na kita ito kuan. Diri na kita diri na kita section. Pananglitan may kita section. Oh, nice. Tapos an neutral axis, or let me use this one. Okay, so we have here the neutral axis. Okay, so let's denote this distance, say this is B. Oops, what happened? This is B. Okay, and this distance, this is say D. Okay. Okay, then your B is equal to say 150 and your D is equal to 350 pananglitan. This is in mm. Okay. And say for example, your section is subjected to a moment equal to 50 kilonewton meter. Okay? Pero in kuan ha, dili board exam or in our quizzes or in your plate, dili ka mo tataganin sugad hini nga na-compute na it moment. Kamo pa it magko-compute it moment, of course, para ma-recall niyo kung paano gyud ko-compute it moment. Okay? Given na an moment didi, pero kamo na ano ba yan? Nagjalagman? Kamo na nga mag-a-answer. Kamo pa it magko-compute it moment. Maya kan lalit problem. Find the stress or the bending stress at the section on the section 2 meters from the left support. So kamo pa it pananglitan, this is the 2 meters. Kamo pa it magbibiling kung ano ini nga magnitude. Okay? Kamo pa ito nit magbibiling. Okay? For now, for the sake of parang demonstration, pananglitan na solve na naton an moment. Okay? Kamo pa it magsosolve it moment. Pero for this example, pananglitan na solve na naton an moment. Okay? So, okay. Pananglitan na solve natin an moment. We are to find for the stress and the maximum stresses. Okay? Bending stresses on this section. Obviously, the maximum stress can be found on the bending stress. The maximum bending stress can be found on the outermost fiber or the outermost layer. Okay, so how do we do that? Masugad. And the formula is FB, and that is equal to MC over I. Pag kita mo pa rin formula, obviously, you have the M, but you don't have the value of C. You don't have the value of I pa. An si masayon la, maximum bending stress pa natin bibiling, di ba? So what's your value for C? Okay, let us identify where M is equal to, ada na given, 50 kilonewton meter. Okay, 50 kilonewton meter. Be consistent ha, ang imo dimension han beam is in mm, tapos ang imo moment is in kilonewton meter. So be consistent. Okay, so if this is 50 kilonewton meter, this is actually equal to, pera ba ito niya? This is in terms of Newton Newton millimeter. Pero it's 50 kilonewton meter. That is 50 times
10
1,000
raised to
times 1,000. Okay. Wait lang. 50 times 1,000. That is 50 times 10 raised to 6. So this is 50 times 10 raised to 6. So di ba? Yung calculator ko pa. Okay. How about the value of C? What's your value for C? Anyone? Okay. The value of C, pero it's C. We are looking for the maximum flexural strength. What do you think is the value of C? The
175.
350 over 2, sir.
Pera? Pera?
175 daw.
175.
175. That is 350 divided by 2. Compute ko pa. 350 divided by 2. 175. So this is 175. This is in mm. Ito na. Sunod an I. What's the value for I? I is the moment of inertia. How do we solve for the value of I? Rectangular man lang ito niya. Okay, take note, I ang ginbibiling with respect to the neutral axis. Okay? And the I for rectangular section, rectangular shape with respect to the neutral axis is just equal to BH cube over 12 or BD cube over 12. The value for B is 150. The base times the height or the depth, which is 350 times 3 divided by 12. And your I therefore is equal to pera ba? Pera? 150 times 350 cube. Divided by 12. Divided by 12, that is, pera ba yung nakuha? 535? Asya ba?
0.937 something.
0.9375. That is times 10 raised to 6 pa, times 10 raised to 6. This is in mm raised to 4. Or better yet, para mas accurate akong answer, i-store ko ini nga value ngadto ha A. Okay, store ko it value ngadto ha A. Delete akong calculator. Shift store A. Nakikita niyo ito akong calculator?
And
No po,
virtual
sir.
sir, waray.
Paray. Sige, basta gin-store ko ya ha A. Okay, so these are the value that we need. Okay, I mean here, value an M, value an C, value an I. So your FB here is equal to, pera ba? Okay, abla mo M, may da C, may da I. Everything is given na, direct substitution na lang adto. Your moment is 50 times 10 raised to 6, right? Times your C is 175. Yun, divided by your I, which I have stored at A. So, yun na natin susulat. That is equal to 16.3265. 16.3265. This is 16.3265. 5 decimal places. 32653. This is in, what's the unit? Take note, this is a stress. Stress ito niya. What's the unit? Okay ha?
MPa.
MPa.
Megapascals.
Yes, that's correct. Okay. Ang atong gingamit nga unit han moment is in Newton mm. Ang gingamit han C is in mm and ang gingamit han I is in raised to 4. So Newton ngayon la an aada han aton gingamit nga mga unit. Okay? Newton ang distance, Newton ang force, mm ang distance. Permiton ha, Newton nga nit force as mm distance, permiton it the resulting unit is always in megapascal. Okay? Always in megapascal. That's why kung makuan ka, if you want your answer to be in megapascal, so dapat tanan nga forces nga unit dapat in terms of Newton. Tapos ang tanan nga forces tanan nga distances in terms of tanan nga distances dapat naka mm. So amoy nira kumbaga nagpaparadis ini nga tutulog. Newton, megapascal. So this is in megapascal. So that's the value for okay. So that's the value for FB. Kain pa itong pan. Pareho lang, di ba? Sa ubos, it will now be in tension. So kung ato ito tawag ini ang stress diagram. Let me draw the pagkapananglitan kukuha natin daw. I-project. Okay. There and here. Okay. And now, what's happening? Uploading. I'm setting the ruler. Okay, so yan. Okay. Dayakan, ang stress daw on the outermost fiber. Rectangular laman hera, di ba? So pareho lang ito hera. 16.32653. So that is in tension and compression. So compression na ito habaw-baw. Assuming nga simply supported beam niya ha. Assuming nga simply supported beam niya. Kasi kung iba nga type of beam, mag-iiba ito nit yan itsura. So this is there. Saan bang tapos wait, not yet that. Okay, yan. So this is in Pirato and value. Value is 16.32653. 16. This is 16.32563. This is in megapascal. Compression. Compression niya ha. Compression. Or kung din na ni-use ang compression, butang na lang yun, negative 16.32563 megapascal. Negative hiya. So, dili ha, ubos naman, this is positive, this is in tension, 16.32563 megapascal. So, basically, the same. Okay? Now, ano ba nga sisi yung mga resultant? Diba? This is a stress. Okay? Focus kita din. Hindi din nga diagram. Hini. Okay, ito nga diagram. Okay, so this is a stress. So if it is a stress, it can be represented by a single force. Let's name the force. Let's use this. Let's name the force. The direction of the force. Negative man ano. So tipa ka diha. Left. The direction of the force is to the left. Okay, so ini nga diagram, I need to emphasize that this diagram are actually tiny little forces. Mga forces ito niya nga nakakalat hindi nga area. Okay? Nakakalat dida ito nga area. Kay ini kumbaga iti-3D nga ni naton nasugad man ito niya. Pwede ito anyan hi. Okay, ito 3D ta ha. Ityan hi nga section nasugad ito niya dida. Ano ba yan? Bakit kiri na kadupot? Nasugad ito niya nga area. Nasugad dito. Bakit ba diri na dukot? Okay, nasugad ito nidang area. Nasugad and okay. Kumbaga ini nga area, I feel like dapat diri jero na kong gamit. Ito niya nga area, amin hit yan hi. Nasugad. Ini bang area ini din hi. Amin hit yan hi. Okay? Tapos ini nga diagram, parang may dapit niya dida nasugad. Okay? Nakakalat. Kumbaga, prism ba? Nagigits niyo. Ano nagigits niyo kay...
Yes po, sir.
Parang nasugad. Sugad. Tapos ini mga forces ito niya nga ito. Nagigits niyo.
Yes po, sir. Yes, sir.
Ini. Very good. Okay. I-erase ko na ha. Nagigits niyo. Okay. Ito ha. Ini nga stress, nakakalat ito niya din ini nga area. Ini nakakalat din itong area. Okay. Now, since this is a stress, it can be represented by a single force. Let's name the force C to denote compression. Okay? So, we will solve for the value of C. Okay? Now, nayakan kita dito, kung mabalik kitahan, simple stress. What's the formula for stress? What's the Naghahang man ito akong stylus.
Stress is
Maybe
equals to force over
stress is equal to force over area. Diba?
area.
That's the value
Yes,
of the
sir.
stress. Stress is equal to force over area. Now we have the stress and we want to represent the stress in terms of its equivalent force, right? So based on this formula, we can write this as, if we are trying to solve for the value of force, the force is equal to the stress times the area. Di ba? Amo ito niya. The stress times the area. So, amo ito't mabuhaton pag solvehan equivalent force represented by C to denote compression. So, how do we do that? Okay. Compression is equal to, kana to stress times area ha. So, ano ang stress? Aliman ang stress. Negative 16, didi habaw-baw, tapos 0 haubos. So, nagva-vary hiya. Ano man nga magnitude, it imo ibubutang hiton dida. Okay. Since nagva-vary man hiya, it imo ibubutang magnitude is an iya average stress. Nagva-vary man hiya, di ba? Average stress ito yung gagamiton. So, rectangular, average stress lang ito niya is ig-adla an negative 16 tas ang 0 tas divide 2 kay average man, that is 16 negative 16 times negative 16.32563 plus 0 divide 2, di ba? 32563 plus 0, di ko na ibubutan plus 0, understood na ito niya nga may plus 0 over 2 excuse me 16.32563 over 2 That's the stress times the area. Adi man mo area. An area kung hain nakakalat or nag-a-act ito nga uniformly varying load with a magnitude of negative 16.32563 on the maximum and 0 on the minimum. Okay, so anhito nga area, ini nga area. This one. And that area is equal to 150 times half of the 250, which is 175, right? So ibutang ni really 150 times 175. Yan, that's the area. So your C therefore is equal to pera. Alayon daw, sige daw.
Negative 214,273.
Negative 214
Yes, sir. 273.
to 73 unit.
89. Kuan.
Point ano pa? 5
Point
decimal
89.
places. 0.89. Okay.
8938.
Come again?
8938 newtons.
938. This is in Newton. Again ha, kay ano, mo 16.325, that is in megapascal. Your 150 is in mm, 175 is in mm. Everything is in mm and megapascal. So ibig sabihin it force nga maging resultant force. Resulting unit, maging resulting unit will be in Newton. That's why this is in Newton. So in kilonewton, this is equal to, let me put it here na lang ha. C is equal to negative 240. Wait lang. Are you sure it is 214?
Amo gihap anak nakuha,
Same
sir.
po, sir. Na-solve ko. 214, sir.
Let me. Parang ang laki naman. Okay. That's it. Okay. 214. Okay, as is na lang natin ano, pa kay later, wait lang. Makikita niyo. Okay, so as is lang natin as Newton. So this is 214,000 273.8938 Newton. Okay. Yan. And another way to solve for the value of C, i-drawing ko nga how ang 3D kangina, no? Nasuga di ba ang 3D? This is the area where your stresses are nakakalat or acting. Tapos amin ang pinaka-maximum, nasugad. Di ba nasugad? Sa amin ang mga area dito nakakalat. Diba, nagigets niyo? I hope nagigets.
Yes, sir.
Okay. Another way to solve for the value of C is to solve for the volume of this one. Sige daw, i-solve natin yung volume. This is rectangular prism, di ba? So to solve for the volume, we just need to solve for the base, the rectangular base. Then we multiply it with the height, kumbaga, ang iyang pinaka-altitude. Pero although the altitude kay parang tumba man hiya. Okay, so that is, what's the formula for triangle? Diba? 1/2. The base, adi niya pinaka-base, adi niya pinaka-height. Triangle man ini. Ba triangle ini? Adi man, triangle ini. The formula
Yes,
niya is 1/2. The base is this one, adi baw, that is 16, negative 16.32563. 1/2 base times height. The height is, pero ba? 175, right? 175 multiplied by pinaka-altitude or pinaka-height or ini nga distance. And that is perabyte nga distance. And B, di ba? Yung B mo is 150. 150. Di ba pareho lahera? 150, 175, tapos ang 16.325 over 2. Pareho lang itong hera. So the result is still the same, negative 214,273.8935. So kung baga kung nalilipuan ka na nga ni, i-drawing, i-3D, tapos volume ito, namon itong hiya, an equivalent force representing that stress diagram. Okay? So amo itong hiya. Okay, now, as you can see, okay, let me erase this one para di kita malipo. Erase ko ha. Naka-record man ini. Tapos calculate value is C. Kaya C is equal to ngayon pero ito 24. 24, right?
Yes, sir. 214.
214.
273.8938 Newton. Okay, so basically they are the same naman, di ba? 16.32563 megapascal, di 16.32563 gihap megapascal. The only difference is their direction. Positive iya because it's to the left. To the right. To the right it iya direction. Oppositely directed here, di ba? Yan. So basically, pareho gihap it ira distance, ini nga distance, tapos ini nga distance, ini nga area, they are the same, but ang iya magnitude and mga stresses are also the same. This is just a rectangular section. So ibig sabihin, an force nga ma-represent hini nga kuan, which is directed to the right, denoted by T to denote tension, is just equal to negative lagi na, positive na, kaya niya direction is to the left naman. 214,273.8938. This is in Newton. Diba? Internal reactive result. Ano to? Nakalimutan ko ang term. Analysis of external reaction and internal stress resultants. Internal stress result. Can you still hear me? Nababatihan pa ba ako?
Yes, sir.
Yes.
Okay.
Sir.
Nice. So this is the internal stress resultant. Ini nga tinghan C. Okay. Di ba magpareho man era direction, no, not the direction. And era magnitude are equal, but they are oppositely directed. What do we call that type of forces?
Couple.
Couple. Okay. You know, to him, Maurice.
Sir.
Maurice, how do you solve for the value of the moment of a couple? Balik kita dili. Let's talk about
Loss.
couple. Nababatian pa ako?
Yes, sir.
Okay, couple.
Yes, sir.
At couple ito, duduha ito nga forces, oppositely directed, but of the same magnitude, separated by a certain distance. Let's name the distance D. Okay,
Yes,
let's
sir.
name the distance as D. The distance between them is D. Okay, say this is F1, this is F2. Okay, if they are of the same magnitude but they are oppositely directed, couple ito niya. My question is, how do we compute for the moment of a couple? Maurice. Dumas.
Force times distance, sir.
Very good. Okay. Bisan hain nga force, di ba? Kaya anyway, magpareho man lahera. So, bisan hain nga force. That is equal to force. Let me put it there. The moment is just equal to the force times distance. Okay? Hindi ni fun nga kuan. Okay, so the moment is equal to force times distance. So, as you can see, if the force of the two couple are constant, your moment will increase if the distance between them increases. Diba? So this couple in engineering mechanics, they seem to defy odds because as they go farther with each other, their moment tends to go higher. Diba? Unlike in real life couple. Charot. Okay, anyway. Okay, so moment of a couple is equal to force times distance. Anyway. Okay. How do we solve for the moment? What's the moment here? Okay, dili na natin igmamay dito nga negative sign na because the negative sign only indicates the direction of the force, so it does not matter. Okay, ginbiling natin ang moment, hand couple. Okay, what's the moment of the couple? Or before natin mabiling, moment it couple, ano ba ini nga distance? Bibil mo lang natin ini nga distance. Tama ang distance laanay. Okay. Di ba? Okay, focus lang kita yan hidin ini. Ini nga rectangle. Triangle, I mean. Triangle man hiya ano. Okay, let me use this one. Okay. Okay. What is this distance? Triangle here, di ba? So madali lang pagbiling, it's centroided triangle. Di ba? Madali lang pagbiling, it's centroided triangle. Pero man nga distance. The centroid of a triangle is 1/3 from the base, di ba? 1/3 from the base. 1/3 ito hiyahan altitude. This is the altitude. And that is 175, I think. Yes, 175. 350 divided 2 is 175. 175 divided by 3, pera ito niya.
58.33.
58.3333.
Oh. 58.33. Kung 75 na lang over 3 para accurate it aton answer. 'Di ba? Asya ba? Asya ba? So pero man
Yes,
ini
sir.
din ini nga distance ang nabibilin din 2/3.
Yes,
Diba?
sir.
Times 2. Pero man ito niya.
350 over 3.
Okay. This is 350 over 3. Okay. So 350 over 3. This is also tika gihap nga da. This is also 350 over 3, right? Do you agree? Para humala itong hera didi.
Yes, sir.
Inigihap nga distance, this is also 175 over 3. So 350 over 3 gihap itong hera dida. Okay. Pero nakita distance, when we are trying to solve for the moment of the couple, that's just equal to the magnitude of the couple, which is, pera ba itong hera? 214. 273.8938 Newton. Newton times what's the distance? 350 over 3 times 2. Pera ito. Pera ba? 350 times 2/3. Pera ba? This, pera. What's times 2? 700 over 3. So this is 700 over 3. Diba?
Yes, sir.
350 over 3 plus 350 over 3 is 750 over 3. Perabyte distance. I mean, perabyte result. When you multiply the two. This one
49
and this.
million.
Pera? Times
Sir, 49 million.
9 million. 14273.8938. 49 million. Kaya ano 49 million? Di man. Okay. 1, 2, 3, 4, 5, 6. 49 million. Sige daw, i-dictate daw. Sige daw. Number 499.
997,241.
49. 49. Asa pa ka 9?
Yes, sir.
Na 499.
7241.81. 89.
241.
41.89.
Unit. What's the unit? This is in Newton.
Newton
mm.
millimeter.
So we can express this in terms of kilonewton meter, di ba? So we just need to move the decimal point 6 times to the left. 49 point. This is equal to 49.997. This is in kilonewton meter. Okay, 49.997 kilonewton meter. Okay, so this is almost equal to 50 kilonewton meter. Actually, supposedly dapat 50 kilonewton meter ito niya. But since diri man accurate ang atong gamit didi nga mga decimal points, that's why may nakita error dida. Okay, pero dapat 50 kilonewton meter ito niya. Ano ito niya nga 50 kilonewton meter? Kaya kitaan niyo. Pira baan moment nga ginkuha na? Di ba naman? Loading na naman. 50 kilonewton meter and moment nga na-experience didahin din hinga section. Okay? Amo iton gihap ityada nga 50. Okay, ano bang nangyayari nga akon? Amo gihap ito niya nga 50 kilonewton meter. Okay? So what's the difference between the two? Ini nga duduha nga 50 kilonewton meter. And adi nga 50 kilonewton meter, amo iton hiya and moment nga na-induced, ibig sabihin that's the applied moment or the induced moment. Tas adi naman nga 50 kilonewton moment, that's the reactive moment. Diba? According to Newton's third law of motion, in every action, there is always equal and opposite reaction. Diba? Oh, balik kita nga diha, balik kita dili. Pananglitan, may dakita dilian. This is our beam. Ini nga beam, section la ito niya didahan. Section la ito niya didi. Yan. That's the pananglitan ini nga section is this section. Ada dito nga section dida. Ada dito nga section, di ba? Tapos usually it moment is papasugad it moment ito. Let me erase this one. Okay. So it, di ba ang shear nasugad, ang shear, tas ang iya moment nasugad. Counterclockwise, positive. Ay positive man ang ginhatag nga moment, di ba? 50 kilonewton. Counterclockwise. Counterclockwise ba ito? Or
Di ba sir, may dayton bagat direction like kung itim gin ko consider is to the left of the force bagat may dayton direction ambot sir nanhingalimot nagkihap mo.
okay. Let's not dwell on that. Kahit aton kasi focus din is the internal reactive forces, ang mga internal, ang mga nahinanabo dito ang sulod. So anyway, basta what I'm trying to point out here, on this section, because erase again. On this section, which is, say for example, amin din nga section didahan, kabuuan beam, because of the forces applied to the beam, pananglitan na din mga forces ang gin-apply didahan beam, okay, because of that forces, okay, nagkakamay ada kitahin, didahiton nga section, nagkakamay ada in induced moment. Okay? Kasi kung imo nga ni i-drawing an moment diagram, di ba nasugad dito yung moment diagram, nasugad. So, ini nga moment din an moment itong dida nga section. Okay? An moment din nga section, ini nga moment. Amo ito niya nga 50 kilonewton meter. And this moment is the induced moment due to the applied load. Or we can say, ito nga moment, amo ito niya an applied moment. Okay? Okay, an induced moment ito niyahan mga applied load. Now, because of that moment, ito nga section nakaka-experience in moment nga 50 kilonewton meter. Oh, your section daw or your structure have to be on state of equilibrium. And for it to be in state of equilibrium, the Newton's third law of motion should be satisfied. And it says that for every action, there's always equal and opposite reaction. That's why ito nga applied moment or the induced moment will be countered with the effect of the fiber. Ito na ang mga fiber, syempre magre-react ang mga fiber. Some of the fiber will be tense, some of the fiber will be compressed. Okay? And the net force nga makikreate ito nga mga tiny reaction and mga fiber will accumulate to a total of the 50 kilonewton meter, which is equal to the applied moment dida nga section. Nagigets ba? May iton hiyaan sinisiring ditohan aton topic nga ano ba to internal stress resultant. So in here mga amit yan mga resultant and mga stresses. So the internal stress resultant. And that the accumulated, the net effect of that stresses, of the resultant of the stresses is actually equal in magnitude equal to the applied or the induced moment. But opposite in direction. Okay, kay Newton's third law of motion. So amo ito niya. Okay, so that's how we do it, okay? So amo ito niya. Now, sometimes in the okay. Wait, diri pa nga yan. Wait lang, na-excite akit one. Okay, so amo ito ha? Okay. Now, diri man la rectangle it ko it aton type of beam. May dakita I-beam. Okay, di ba? May dasugad dito nga sugad nga I-beam. May dakita I-beam. very symmetric it ako an I-beam. Pero pasensyahin na let ni. May kita rectangular beam, of course. May kita T-beams. Manasugad mga T-beams. May have I-beam pero mag-iba it flanges. Ano ba ibig sabihin? Mag-iba it iya width and flanges. Ano ba? Ano? August, kutob lang ada. Tsaka. Na si center. Yan. Nag-gets niyo? I-beam gap ya, pero ang flanges. Flanges kasi tawag ini, di ba? Mag-aral naman kami ito nit mga tawag. Lalagtalapit ako ng Microsoft. This is a flange. These are flanges. Mga flanges ito ni tawag ini. Okay? Flanges itawag ito. Ito naman, itawagin na iya, web. Web itawag ita iya. Okay, mga web. Webs and flanges. So ano sa magparihuan I-beam niya, magparihuan width and flanges sa ubos nga nabaw-baw. So it is centroid, lagi hap. Masayon la. Okay. Ano sa naman may dakita I-beam. So waray niya flange sa ubos. So it is centroid is parang skewed upward iya kay mas mabugat man habaw-baw. So ma-adjust gyapon nimo centroid. And therefore your neutral axis. The same with this one. So somewhere here iya basta skewed to upward here. So somewhere here. Yan. Okay? Ano to? Nawara ako akong train of thought. Ano to nakikidiscuss? Nakalimutan ko. Ano dito? I was discussing about the ano pero hindi discuss, wait lang. Okay, never mind. So I'm gonna hit different types of beam. Okay? May da pa. Kung naparayaw it architect, may daghap ito beam nga circular. Okay? So sugad iton. Or sometimes triangle. Okay? May dahiton mga sugalit nga instances. Mga itawag na iya mga beams are decorative beams. Okay, mga decorative ito niya mga for decorations. So if that's the case, dapat maaram gyud ka mo mag-compute how to design these types of beams. Okay? Kalimutan ko na ako i-discuss. Anyway, never mind. Okay, so aman hiya itkoan. Aman hiyaan sinisiring naton nga stress resultant. Okay, so that's it. So kumbaga, ayun, okay. I remember na. Okay, for this one, okay. Let me erase this one. I remember ko na. Malimut na ako. Okay. If we want to draw the tawag ito niya an iya stress diagram. Okay. Itong stress diagram will look like this. So, ganda. So this is maximum. Ito ha, baw-baw. 0 at the neutral axis. Masugad. Ba, parang same lang ahaw. Kay ay man lahiya, di ba? So the same and flange and with hand flange di habaw-baw as and with hand flange di haw. So it iyan stress diagram similar lang ahaw rectangular. Okay? Yan. So, lang nga. Okay, as you can see, anyan nga portion han imo stress, di ba? Anyan nga portion han imo stress. Nakakalat hiya didi. Okay? So, atas alin naman nga portion han imo stress, nakakalat hiya didi. Ibig sabihin, di rin mo hiya pwede kuhaon an average niya nga stress, tapos ikakalat ni mo didi nga area. Okay? Mag-iiba ito net imo value because of the fact na yan nga stress nakakarat didi, tas adi nga stress didi la. So, di rin mo hira pwede combine because mag-iba it area kung hain hira nakakalat. Di ba? So, di rin mo hira pwede i-combine. Okay. Ito niya na, duduhayat imo force nga i-solve. Madani mo force. Let me get this one. Madani mo force sanyan hilinhi. Madani mo force sanyan hilinhi. Okay? So, adi trapezoid, adi triangular. Similar with DD, how goes? Madani mo force DD, tapos madani mo force DD. Kung pareho man lang hira, so, couple lang nga how it ka-resultant ini. It resultant ini, couple lang nga how. Okay? Now, okay. Now, yan na. May da na nimo flange, may da na nimo web. May da nimo flanges, may da na nimo web. The common question, did ha board exam or? Yes, a board exam. The common question will be, say for example, gintag an moment, an moment itong dida nga section is, say, for example, 50 kilonewton meter. Pananglitan lang. 50 kilonewton meter. Okay, the common question, ha board exam is, how many percent, di ba maara naman kita nga, ini nga moment will be countered by the internal moment. Kumbaga, ang couple, ang magnitude han couple, lead to han mga internal reaction. So, ito yung 50, pag i-carry ito, i-counter hini nga mga forces, ito nga mga couple. Okay? Now, the common question is, how many percent of the moment, ini nga moment nga 50 kilonewton, is carried by the flange. Okay? How many percent of this moment is carried by the flange? And how many percent is carried by the web? Okay? So, amo ito net common question. The percentage of the moment carried by the flange and the percentage of the moment carried by the web. Okay, amo ito net common question. Similar with this, one. Okay? Sige daw, sample problem lugod kita. 7 pala, o nakapatat oras. Sample problem lugod kita para niyo makita. So, ano yung solve? 50 kilonewton lang ako. Sige, 50 kilonewton. This is again your neutral axis. Okay? The given are, say, for example, nalalabaw ako ibubutang ha. The width of the flange is equal to, say, 300 mm. The width of, or the thickness of the width of the web is equal to, say, 100 mm. And ano pa? The thickness of the flange is equal to, say, 100 mm. And with the web, ano pa? Overall depth is equal to about 100, 100, 300, 500 mm. Okay. Again, did it you quiz or did it you plates? There ito hatag it drawing, what ito figure. Adila ito nit ihahatag. So you should be able to know how to interpret it. BF is the width of the flash. Basta B nga ni permiton hiya width. Diba? Kung nahalata ni permiton it B, di man. B permiton hiya width, diba? Width. Permiton basta it B width iton hiya. So B sub F, that's the width of the flange. Flange, maram nakitahan flange ha. These are the flanges. Ini. The width of the flange, so ito naglo-loading na naman. Okay. So ini nga distance, ito yung width of the flange, that is 300. The width of the web, ito nga width of the web. Adi man tim web. So ini nga distance, ito niya width of the web. Because this is your web, plus ang width niya, niya nga distance. The width of the web. Thickness of, or sometimes this is the thickness of the web, TW. Sometimes lang hindi denote TW, thickness of the web. Pero mostly, ginagamit ito ni BW, width of the web. TF naman, T sub F, T is the thickness of the flange. So ano ito here? The thickness of the flange is this one. This is the thickness of the flange. Yan. D is the overall depth. Or sometimes, in RCD kasi, D is the effective depth. So let us not use D na lang for the sake of our uniformity. Para diri ka mo malipat pagkatunit RCD. Let's use H na lang as the overall height or the overall depth. That's the height. Okay? Yan. Okay. Okay, let us solve for the value of the moment on the outermost fiber. How do we solve that? Sige daw. FB is equal to NC over I. M is given. What's the value of C? Using the overall depth or the overall height, that's 500. So the C, the distance of the outermost fiber from the neutral axis, is just half of the 500, which is 250, right? So M is equal to 50. C is equal to 250, diba? This is in 50 kilonewton meter. This is 250 mm. Tapos, an I I is the moment of inertia. So how do we solve for the value of I? Okay. This is very interesting. Diba? Okay, so this is your figure. How do we solve for the I here? Diba? Tutuloy imo area din. May nakita sinisering nga transform area. You include this in your in your assignment, the transformed area. At the transform formula. Tapos nakaman yung plates. Transformed formula for moment. Loading again, moment of inertia. Okay. Transform formula for moment of inertia. What? Ano ba ito mga transform? Ba yan? Bakit naglo-loading? I at NA ha, always at NA kita with respect to the neutral axis. I at NA is equal to the summation of I NA plus area times D squared. Di ba amo ito niya? Familiar kami ng formula. This one. Ito ka nga ni familiar, balik ka, statics. Okay, so that's the transform formula. How can we solve for this one? I-solve natin ang moment of inertia with respect to the neutral axis. Okay, and we will use this formula. Okay. This formula is only used if you are dealing with composite figure or if you're trying to solve for the value of the moment at any axis. Okay? Okay, again, this formula is used in solving for the moment of inertia if the given figure is not a regular shape, if the figure is made up of several regular shapes, ibig sabihin composite shape here, they're here regular shape, or if the movement ng bibiling is with respect to any axis, with respect to an axis, not the neutral axis. Parin ako. Okay, ikaw ako na, i-drawing ko na lang. Pananglitan, you have this rectangle right here. Let's say, for example, this is 2, this is 3. Okay? 2 inches and 3 inches. Tapos, adi naman ang axis. Adi nga axis, ano mo yung upan. So, this is the distance. Meaning, a distance is, say, 4 inches. Find the moment of inertia of this shape with respect to this axis. Paano man? Pasok ka dito, ha? I, with respect to this axis, is equal to, using this formula, okay? Summation of, kaya ano summation? Because this is intended kasi for several composite shapes, di ba? Pero kayo usa man lahiya, ayun na pag-summation, na na lang INA. What's the INA of this one? The INA of that one is 2 times 3 raised to 3 over 12. That is BH cube over 12, ba? BH cube over 12. Plus, ano na ha? AD squared, the area, which is 3 times 2 times, that's the area pa lang ha, area 3 times 2 times D squared. D is the distance from the centroid of the area. Yeah? D is the distance from the centroid of the area to the axis you are getting the moment of inertia. So for here, this is equal to 4 plus half of 3. Diba? Ini nga distance, ika di centroid nga di. That is 4 plus half of 3, which is 1.5. That is 5.5. Yes, so this is the value for I. The I is whatever is the value here. Okay, amit paggamit ito ni transform formula. Okay, amit ibig sabihin ni INA, amit niyaan moment of inertia of each individual shapes, or yes, each individual shape with respect to each individual neutral axis or centroid. Amit niya INA. Summation kay because of the notion nga damo nga composite shapes. Okay, and A naman the area of the shape, tas D is the distance of the centroid of the shape to the axis where you are trying to get the neutral axis. Okay. Now, how do we apply it here? Okay, so before we can apply it, let's divide this laanay into several composite shapes. Okay, haliban. Adi and DD. So we have here A1, A2, and A3. Tutuloy at regular shapes. So composite shape here, pero made up of regular shapes. How do we solve it here? Okay, summation of NA laanay. Summation of NA, ibig sabihin, ang NA han A1, INA han A1, that is, pero ba ang mga dimension nila? BF is 300, TF is 100. So nasugad it aton shape. 100 tapos, sorry. 300 tas 100. Diba? Kasi ito, nit yan A1, 300 plus 100. 300 and 100. So, didi, that is base times height raised to 3 over 12. This is equal to 100 times 300, sorry, mali. 300 pala. 300 base times height, which is 100 cube over 12. Okay, that's the INA. Plus, ano pala ito niya? Adiha ubos, or adala nga A2. The base of A2 is the width of the web. The width of the web is 100. So parang nasugad. 100. What's the distance naman niya? That's the height. If this is 500, di ba 500 an overall height? Tapos ang thickness and flanges is 100. So 500 minus 2 hanggang 100, 300 ini. Do you agree? Asya ba? 300 pa.
Yes, sir.
Opod sir dida uncentroid dida napas po didat bot nga uncentroid. Iton nga shape sir. Or above the centroid iton sir nga
No. Dito nga area.
Oh yes sir. Walang sir 300 na sir.
Okay? So, put it on an area. So, that would be, pera ba? Base 100 times 300 cube over 12. Yeah. Let me erase this one. I think I made my point here. Is
Sir, an AD
plus.
squared.
Wait lang. Adi pala kita INA. Okay? Plus, ano katulo pa? Adi. Similar with this one malagyap, di ba ya? Ano sa nga plunge? Ibutan ko na rin plus 300 times 100 cube over 12. Nakuha niyo kung din ito nga formula. BH cube over 12. Sa ito niya. Okay?
Did you get it? Some?
Yan. An summation of INA pala ito niya. Plus, again, the summation of AD squared. Okay? Adit imo neutral axis. Okay, kita. Since these are symmetric, ini nga figure kasi, anaton beam is symmetric on both axes, both the x and y axis, di ba? So, symmetric man niya, madali lang pagbilihan centroid. Ada net centroid, ada neutral axis. So, ini nga A, that's the area of each shape, regular shape, A1, A2, A3. That's the area. Tapos i-multiply nimo itong D squared. Take note, D is the distance from the centroid of each shape to the neutral axis of the whole, of the composite shape. Okay? The neutral axis of the composite shape is this axis. Ini nga D, distance ito na neutral axis of A1 of each area to the neutral axis of the whole composite shape. So pananglitan ang A1. A1. Let's put it here. The centroid of A1 is somewhere here. Diba? The distance of that centroid to the neutral axis. So basically, the distance of the centroid of A1 to the distance to the centroid of the composite shape is this distance. Amin hiya ang D1. D1 to indicate for area 1. Okay. And A2, and D2 and A2 is 0 because nagko-coincide mala itong hera. The distance of the centroid of A2 to the centroid of the composite shape is 0 because they coincide. So 0 na. Okay, and A3 naman, centroid niya is somewhere here. Let's put A3 there. This is the centroid of A3 and this distance, amin niya and D3. D1 and D3 are just the same, di ba? Pero ito niya, let's solve for the value of D1.
200 po, sir.
200 ba? What's the overall depth again?
500.
500.
What is this distance?
250.
250,
Yes, sir.
right?
250.
Yes, sir.
How about this one?
50.
50.
Di ba? Kay 100 man ang thickness and plunge, katuma ito 50. So, ini, makukuha na nato. And that is 250 minus 50, that's 200, right? Masayon nila, di ba? Masayon nila kung kung may presence of mind. This is, A1 na kita. What's the area of A1? That is 100 times 300 times, what's the value of D? 200, di ba? 200 squared. Don't forget squared. Nayakan ba yun? AD squared. Yan. And AD squared pala inihan, A1. May dapat kita AD squared and A2. And A2. What's the value for A2? The area of A2 is 100 times 300. 100 times 300 gyud, di ba? Di man, adiyan natin A2, di ba? And A2 didi, here, 100 times 300. Times the distance niya is 0. 0 man, di ba? So supposedly, dapat wala natin mag-isulat dito. Because the centroid of A2 coincides with the centroid of the composite figure. Plus, an A3 naman, basically the same. This is 100 times 300 times 200 squared. Di ba? Pero man in A in A.
Why you just screenshot ng every process?
Pero I in A.
Okay, this one naman.
Puro niyo i-solve ano. Dapat compute na. Okay. We have 300 times red cube.
What is your base of all?
Wow.
Digital nursing is going to based on all the
Plus 100 times 300. Wait lang ha, compute ko. Compute naman ka mo para may nakita ma-check natin if you have the same answer. What's your answer? 175.0808. Raised to 4. Asya ba? Did you get the same answer? Class? Hello?
Anak nakuha, sir, 2.65 billion.
Sure.
Amo na, sir. Recheck ko na, sir. Kaya mo anak nakuha, sir.
Wait lang. Check ko gamit ako ng input na calculator. 300 times 100 cube over 12. 100 times 300 cube over 12. 300 times 100 cube over 12. I think. How about the others? My answer is 275.0808 times 10 raised to 6. So 275 million 800. Oh, yes. 275.00 times 10 raised to 6. Anyway, sige, i-recheck lang ninyo. But I think asya na yung answer. Kuha lang, paki-recheck lang. Bakit may sabit ako nito? Calculator. Please recheck. Alayin paki-recheck.
Press anonym answer.
2.6...
675?
2.67. Opo.
Same naman ako.
Tapos, oonam nga 0.
Same answer kita. Ibig sabihin mali kita.
Agoy.
Ano makuha itong Dawitin? Sugat.
Amo pa niyo, pre.
Oo, sige pa na ako. Parang kami. Oo, mo na.
Mali kita.
Tawarin mga rocket.
Dire kita mapasarhin eh.
Oo, maray.
Ikaw, Master Kant, ano ni yung answer?
Diri na matikan.
Yeah, mas ray ni kung ganito.
Hello?
Sir,
Did you-
2.675, sir. Same
Sir.
ba answer?
Same?
We
2.6
got to ay
Amon ko, sir.
may namon collective conclusion talaga sir nga 2.675.
Oo, so ako sa'yo. Ano yun?
Ambot las.
Bakit hindi kami, sir?
Bakit sir ka
Ayun na,
ba
wait lang,
sa'yo?
let me recheck. 300. Bakit ganun? Bakit ako sa'yo kay appropriate you answer?
Pair. 116 is the pair. Where's the pair of 4?
100. Okay. Tama. Ako sa'yo. Kaya alam kong kinukuha din ni plus 100 plus 300 plus 200.
Yay.
So ba yan? Times. So 100 times 300 times 200 raised to 2 times 2. Kaya parang malit yan hingat yan eh. So the answer is 160. 2.675 times 10 raised to 9. Siya ba? 2.675
Yes, sir.
times 10 raised to 9. Let me erase this. Okay. So this is perato 2.675. Siya ba? Times
Yes, sir.
Yes sir.
9. Siya ba?
Yes sir.
Unit.
Is my second note.
Sige daw. Unit. Moment of inertia. What's the unit for a moment of inertia?
MM raised to 4.
This is in Okay, so added aton INA. Di ba? Kaya pag-solve it INA. Moment of inertia pala ito. Ada pala itong dida. Moment of inertia pala itong iya. Ang ginpapasolve imo an FB. No. Ang ginpapasolve imo is the percentage of the moment carried by the flange. Waray pakita ikato nga solution. Ada pala kita hit moment of inertia. Diba? Kita i-explain ko ayo kung gaano ka ihap pagkuhit moment of inertia. Kita aniyo kung sugad hini if you figure. Ani ha? Dili. Anya di nga figure, masayon la ini ha, masayon pala ini. Kumbaga grade 1 pala ini ha, grade 1. Na-answeran ini akon umangkon nga grade 1. Okay. So, masayon niya in the sense that you don't have to solve to locate the centroid because symmetric ya on both axis, the x and y axis. Symmetric man so masala pagbilikit niya centroid. How about this one? Diba? Kailangan mo pa i-locate its centroid. Kaya ano kailangan i-locate its centroid? Because in solving for the moment of inertia, you need this value. Diri nakakuha. Diri naka Hello, may diri naka ano. Pinyaran ka damo ganit imo food dida. Diri ka man naka ano.
Siya. Te.
Diri nga ni pinyaran ba?
Sorry. Sorry, sir.
Ano ba?
Mga round kasi, sir. Sorry.
Pangaon. Diba? Ano na to? Okay, kailangan natin malocate ang centroid because we need that in solving for the value of D. Ano to ang D? D is the distance of the centroid of each individual shape to the centroid of the collective collective shape na, ang composite shape na, di ba? The distance of the centroid of each individual shape to the collective composite shape. So, madidetermine mo lang D if you know if you know the location of the centroid. Okay? Pag locate palit centroid, kung diri ka nga maaram, ada kay di ka makaka-answer. Kaya kailangan itong pag-solve D. Diba? Waray pa ito niya, diri pa ito niya 1% ang imo ginsosolve. Kaya yung papabiling ha imo is the percentage. Okay? So dapat, what I'm trying to point out here, this is supposedly dapat din ko nang i-discuss din hit pag-solve it moment of inertia. Because dapat na-discuss na ito yan, statics of rigid bodies. So if you can't recall, and I'm sure can discuss ini iyo, if you can't recall, try to recall. If you can't recall, review. Pag-review ka mo. Di ba? Pag located centroid, review ka mo pag located centroid. Yung gamit malay ito niya is Varignon's theorem. Varignon's theorem lang yung gamit pag located centroid. Okay? Balik kita rin Damo na tap, gininakan. Ang ipapabiling natin is the percentage. Okay, so we already have the value of I here. What's the value for I? That is 2.675. Siya ba? 675. Get that. 2.675 times 10 raised to 9. Times 10 raised to 9. This is in mm raised to 4. Yan. So, makukuha mo na ng FB. Piraman. Sige daw. Piraman. Ano yung formula? NC over I. That is your M is equal to 50 kilonewton meter, or that is 50,000. 50 times 10 raised to 6. Kay naka-kilonewton meter ka man, di ba? This is supposedly dapat naka-newton mm. 2 times 10 raised to 3 times 10 raised to 3. That is times 10 raised to 6. 50 times 10 raised to 6 times C. Excuse me. Times C, the value of C is 250 all over the I, which is 2.675 times 10 raised to 9. Then you'll have the value equal to 4.67. Asya bet in ako ha? 4.67897.
Yes, sir.
Yes, sir.
Kindly dictate daw nga 4.6. Nangalit ako.
289.
7289.
7196.
Sige, ubos na 7196. Or better yet, store natin yung adtuhan para direct ko na sinurat via calculator later. Okay. Okay, ada. We have the FB na. Kahit nga FB didi. Ito nga FB. Dito nga FB, di ba? Anyan hi. So, that is 4.67289. Megapascal ha? Megapascal. Negative because that is in compression. Tapos sa ubos naman, positive 4.67289 megapascal. Tension, that's why positive. Yan. Meron na kita mga stresses. Aton sa solve naman nga sunod, ang mga forces na nagre-represent sa iya. Okay? So ini nga trapezoid ini nga trapezoid, this can be represented by a single force. Diba? It can be represented by a single force acting on this area, on A1. Okay? Pero makukurean ka because you don't know how to locate the centroid of a trapezoid. So makukurean ka. So instead, it atang ginbubuhat, i-divide further natin into two shapes. Parang i-divide natin into rectangle. Nakita niyo? Rectangle and triangle. Trapezoid kasi is not a regular shape. You cannot it's not a regular shape, so parang makukurean kapag solve it is centroid later, di ba? Kay moment of couple bayad aton kinahanglan, so dapat maaram ka kung hain it location it centroid. Makukurean kapag pag-locate it centroid hit trapezoid. That's why i-resolve natin ini. I mean, i-cut natin here into regular shapes, rectangle and triangle. So for the rectangle, let's denote the force then rectangle as this force. Okay? Acting at the centroid of A1, of course, this let's name it as in compression 1, so C1. Let's name it C1. Tapos may nakita another force. Okay, dinala. May nakita another force. Okay, let's name it C2. Ang C1, amo ito niya ang force nga nag-aaktidahan due to the rectangle part of the trapezoid. Tapos ang C2 naman due to the triangle part of the trapezoid. Tapos of course, di diha ubos, hindi nga part din ini nga part. May dani mo dida another force. Okay? And let's name it C3. Okay? Similar ito niya case di diha ubos, pero instead nga C, we will use T. Okay. Let's focus lang na hinidinhi. Let's focus on these three forces. Okay. Manahon natin at C1. How do we solve for the value of C1? Naglo-loading na naman. Okay, C1 lang muna. C1 is equal to, okay, C1, your C1, that's the force in compression due to the rectangular part of the trapezoid. Okay? Ikutan ko rin para i-enlarge ko ha para makita ninyo. Nasugad. Diba nasugad? Tapos, nasugad. Adi, ang rectangular part of the ano. Okay, the rectangular part. Okay, so if pero ito idon. Sana nasusundan niyo. That is 4.67289. Never mind the negative sign because it only indicates the direction. 4. Ano to? Dictate daw. Malimutan ko ito.
4.67289.
4.7. 6.
7289.
4.67289. Yan. That is in megapascal ha. Okay. So, pira ba yung nga distance? Can we solve that? Sige daw. Kung kaya natin ma-solve. Di ba kaya natin
Kaya.
ma-solve?
Kaya sir, hit ratio and proportion.
Linear man lang niya, di ba? Ano ba niya nga it magnitude hini? Hini nga point din hini. Di ba masosolve natin? Ratio and proportion. Triangle, tapos another triangle. Ratio and proportion. Ratio and proportion. Dili kita ha? Masosolve natin ini nga distance. Ratio and proportion. Pero ba ini nga distance? Sige daw. Balik na kita. Use screen ano, balik-balik na, malipong na. Pero yung distance,
250,
this
sir.
is 250, tapos ang
250.
thickness and plunge is 100. 250. This is 250, tapos ini naman, this is 100. Okay? 100 dito. Okay, so in solving for this distance, ini, paano la? Pera ba? Or, adi ha? This one. Using the big triangle, you will have 4.67289 all over. Using the big triangle again, 250. This should be equal to this, using the small triangle naman, ini nga distance, which is this distance, di ba? Let's denote it as x. So x over, adi naman, using this small triangle, adding a distance. That is 250 minus 100. That is 150. Also, name one value and x. What's the value for x? Sige daw. What's the value for x?
2.8.
Pera?
2.803734. Anak na nakuha, sir.
Same, sir. 2.8037.
2.80373. Sige daw. I-dictate daw.
2.803734.
This is in no. Not in mm ha. This is in megapascal. Okay, so that is in megapascal. And value on x nimo is 2. This is 2.80373. Bisan kutob lang ada. Okay, so ini, pira man yun niya. Minus daw, subtract daw, wala yung daw. Kung pira ito niya, 4.67.
1.869156.
8691. Pira to?
1.869156.
6. Asya ba? Round up. Okay, ada na ha? May kita mga value. Round talan and force din yung rectangle. That is the magnitude of the stress is 2.80373, di ba? And this is average stress na niya kay since rectangle naman niya, amo na nga how. Di ba? At average stress, the same lang how ito na niya. Multiplied by the area and ini nga flange, di ba? I mean, ini nga portion of the stress, di ba? Di ba? Ini nga portion ng stress din ni nakakalat here diyan A1. The area of A1 is TF times BF. 300 times 100, di ba? So, the value for C1 is equal to the area which is 300 times 100 times the average stress. That is 2.080373. This is 2.080. Ano ba yan? 2.8037. Yan. Pero in here. This 2 is in mm, plus this is in megapascal. Pero ito din.
Anakon po nakuha, sir, is 84,111.9.
84?
Pascal mm.
Same, sir.
84?
Ang magaba naman, sir.
84,111.9.
84,000, 111.9.
Yes, sir.
84 and 11.9. This is
0.9.
in
Yes, sir.
unit.
Newton mm squared.
Newton lang. Force ito niya. The force that represent this stress, di ba? Adi
Ang
man,
300 times 100, sir.
mm. Mm times mm is mm squared.
Squared.
Megapascal
sir.
is Newton over mm squared.
Oh, yes, sir. Okay po.
Megapascal is Newton mm squared. Since 300 times 100 is mm squared, magkakasilatan ng mm squared. About the C2. 7:40 now. We still have 20 minutes. Okay. C2. Pero ba C2? Adi, triangle, 1/2. 1.86916 times the area where they are in, that is 300 times 100. Diba same lang how? This is equal to pera. .5 times 1.86916. Kasya ba? Your answer.
28,037.4.
Newton. C3. C3 is pera ba? Didi. Okay. C3 is 1/2. Triangle maghap itong triangle 2.80373. You want to ask why 2.80373? Ni kasi nga distance, amo nito niya nga 2.80373. Okay, multiplied by the area where they are acting. Kita ang 250, sorry. Ang C3 is acting on this area, the upper portion of A2, from the centroid to the junction between A1 and A2. Okay, from the centroid to the junction of the web and the flange. So, pero ito nga area, what's the area? That is 100, the thickness of the web or the width of the web. multiplied by this distance that is, pera ba? 300, 150, right? 150. 150
Yes,
kay,
sir.
150. So that is 100 times 150. Pera man ini?
27.975.
Sige daw. 21,000.
27.
27.975.975.
This is in Newton. Wala na. May C1 na kita, may C2 and all. C1, C2, and C3. Okay. Locate naman kita ira mga centroid. Okay. Ang centroid han, ano? Erase this one. Okay. Iya centroid han din hi. Diba? Pan C2. Pero yun nga distance.
50.
Obviously, that is 50. It's centroid, it's hit yan hi nga, tawag ni triangle is somewhere here. Diba? Pero yun nga
250.
distance.
To 100/3.
Come again?
100/3 po, sir.
Okay. 1/3 of 100. But 100/3. This is 100/3. How about this one? This one multiplied by, pero ba? Wait lang ha. This one. Pero ito nga distance. 100 plus
100 plus 150/3.
how much is
150.
that? That's
150.
correct. 100 plus 150/3.
Plus
Pera niya.
50. 150 all in
150.
all po.
Pera?
150 po, sir.
150. Okay, ibutan ko na lang 150 ha. Tama. Kay 100
Yes, sir.
plus 150 mm. Paada, 150. 50, 100/3 ngayon, 150. Meron kita mga location, meron kita magnitude. Okay? So, malolocate na natin. Di diha ubos, pareho man lagi ito nila, di ba? They are just symmetrical. So, kung symmetrical na diha ubos, no need na to solve. Basta sure ka na nga, opposite directed yun. Makaka-create hin couple. Yan, bakit column yung sinasabi? Makaka-create hin couple. Okay. Let's denote the couple 1 as M. The moment of couple 1, M1, is equal to, we will use to find the moment of couple 1, let's use C1. Diba? Kami naman niya kapareho dito ubos of the same magnitude. That is 84,111.9. Ako dito ha? 84,111.9. That is in kilonewton meter. No. That is in Newton. This is in Newton. Multiplied by its distance from the other 84,111.9. Add to haubos. Pero bet ira distance. 50, diba? And total depth or the total height of the beam is 500 minus 50 here. Plus 50 nga to haubos, yeah, 100 minus 100. So, meron natin, pera. 500 minus 100, that is 400. Uy, nag-iihap pa ako. 500 minus 50 haubos, 50 habaw-baw. So, 100. So, that is equal to 400. Yan, that's the moment. Perabyte moment din. M1.
33,644,000.
In terms of kilonewton meter na lang, Mr. I-divide hiya in 10 raised to 6. Yung answer. Your answer, divide it into 10 by 10 raised to 6.
33.64.
Yan?
Yes, sir.
Yan?
476
pa.
64476. 0.64476.
This is in?
Kilonewton
Kilonewton po.
meter.
Kilonewton meter. M2. Okay, so the moment naman, hand couple number 2. So we will use C2. What's the value for C2? Naglalag na naman. Okay. C2 is 28037, 28,037, 28,000, 28,000, this is 8, 28,037.9. Pero ba ito? 0.4 times the distance. What's the distance between the force acting on this point to the force acting on the lower portion of the beam? Pero ang distance niya 100 over 3, di ba? So 500 minus 100 over 3, tapos sa ubos na naman may 100 over 3, that is 50 over 3. Siya ba? 50 over 3. Wait, 100 over 3 plus 100 over 3, that is 50 over 3. Di ba siya ba? 50 over 3. So that would be...
Dire, sir, 200.
200 over 3.
Yes, sir.
Ma-multiply po to kay Dodo yung
200 over 3. Tama. Gin-minus ko. Ginta times. Pero by answer, pero ito i-multiply din eh. 500 minus 200 over 3. Pero ba ini?
12.1954.
Pera?
12.14954.
Ano in kilonewton meter na? Because the resulting
Yes, sir.
unit
Yes, sir.
is in Newton mm. So it's
Yes, sir.
in kilonewton pera man.
14954.
4?
Yes, sir.
149 po.
14954.
This is in... Yeah, hindi po. M3. M3. Pera. The magnitude of M3 is 21,027,975. 21,097. Siya ba? 21,027,975. 7.975 times. Kaya niya distance didi? Tikan din na tawabaw. 150, right? So 500 minus 150 ubos. Tapos minus 150 ubos nga 300 na. So 200 lang akong 200. Pero naman ini. In kilonewton meter.
4.205595.
4.2
055
5595.
559.
95.
Yes, sir.
Asya na ini?
5 na lang,
May
sir.
pa 5, sir.
5. This is in kilonewton meter. MM anak nasurat didi. Let me erase this one. Dari in MM. Yun. Ada na. Ada nakit. Moment. Okay, takay ang ginpapaya ang pinasusolve man na imo is the percentage of the moment carried by the flange. Okay, di kita. Ang percentage na carried by flange, ang mga forces ito ng yanhi, nanyanhi. Okay? By the way, it should be dapat anak kong nasugad. Okay? Sugad. Kung bitangan ka mo hinsugad nga symbol, malidong tapos may exit. Ibig sabihin nito, arrow iton or yes, excuse me. Arrow nga naka-top view. Kung nakita ka mo hindi. Dapat marunong din pa mag-interpret. Anyways. Ay na to. So how do we solve that? Paano natin makikita ang percentage? Okay, para makita mo lang kailangan mo lang ma-solve compare ang kabuuan. Okay, ang couple. Pero man ito, no? So i-add mo lang. M1 plus M2 pera. Alain daw, M1 plus M2. Dapat gin-store na lang niyo iningad to ha A. Tas adi gin-store ha B para diri na kita mag-iha. Dapat pahara ka mag-store. Pero it value Hit M1 plus M2.
45.7943.
45.
0.7943.
7943.
Yes, sir.
Waray na sunod.
Waray na po, sir.
Okay, this is in kilonewton meter. Plunges. About however, siya nito hit kaya nga 4.205595 kilonewton. Ito niya. Siya answer. Diri pa. Kay percentage ang ginbibiling. Pero percentage niya. Pero ang kabuuan. Pero bang kabuuan?
50.
50, di ba?
Sir, 49.9999895.
45.75. 50 ang kabuuan. 50 gamita. 45.7943 divided by 50 pera. Per percentage.
91.58.
5886. 91.59.
% asya na? Mali.
0.58,
So this
sir. 5886.
91.5886. Percent.
Yes,
Percent na
sir.
po ito, sir.
Didi, pira man ito niya. Obos. However.
8.41119%.
Yan?
8.411196.
Tulunga 1, sir.
Tulunga 1. Okay, 9%.
6.
O, diba? O, kung maaram ka na nga ni, nga 91, o, 8 naman it 12. Okay? Sama ito niya. That's how we solve. If the question na yakan pero ika percent if gin ka carry it plunge. Pero in real life, di kami magpipinansolve. This is purely academic. Kasi, okay, makikita niyo yung importance ni. Kay ano nga, okay, kita daw ni design. Kay ano, nga preferred inihiya instead it rectangular nga beam. Okay? Because, okay. Didi kita di. Ito rin pa drawing. Di ba nasugad? Kaya advance kita, this is, we still have 5 minutes. So, before I dismiss you, may ko lang gusto ikon mo point. Mapay kung may daning akong dispatch. Ay, may dadi. At nagpatugtog pa. Okay. Pasensyahan na lahat. There is straight it line. Okay. This is the ano ba ito? F B. F B. I'm talking about the diagram. Hindi ko magkukulang ako in space. Okay, loading naman. Extend. Pasensyahin na lahat. There is straight it ako on drawing. Anyway. So, di ba nakakita natin ang EFV, if B, bending. Nasugad niya, ano, ba nasugad? Iya, ato gini, diagram. Okay din kung rectangle, di ba kung rectangle, iya FV as in victory, iya iton diagram nasugad. Pa nasugad ito. Parang parabola hiya, maximum at the centroid or at the neutral axis, the zero at the outermost fiber. Din that's the same gihap, pero more on nasugad ito niya. May niya sinisiring nga jump. May niya jump because Kaya ano may that jump? Okay. May that jump because of the junction between ano, explain ko na naman, wait lang. Di ba ang formula FV is equal to QV over ID? Okay. Just above the junction is this one. Just above the junction, the value of your B, take note, B is the width of the fiber being considered. Just above the junction, ang imo fiber is yan. Just above, ha? The B is, the width of the fiber is this much, di ba? Okay. Just below the junction, the width of the fiber is this much. Okay? Constant manitanan, constant an Q, constant an B, constant an I. Kay basically ada malayat junction. Now, because of that sudden change of B, may da kita jump nga da. Amo ito niya nga may da jump. Okay? So instead ngayon may da niya jump. Pero basically the same day ito niya degree. May da niya jump tidi pero nasugad lang ako ito niya. Okay? Parang yan hila pero may dala nag-jump. Whatever basta siya tiya. Okay? Sa amin din Sora. That's the FB. This is the FV. Okay. We just proved nga okay, dire. Tsaka i-explain. Wait lang. Let me find the okay. Kung kikitaan niyo din nito if FV, most of the stresses, kaya most of the stresses in horizontal shearing stress is distributed dida ha web. Diba? Dida ha web. Kikita daw, ada man it maximum nga kuan, ada it maximum nga tawag ini nga stress in shearing, in horizontal shearing stress. Ada it maximum. Most of the stresses are distributed dida ha web. Pero pagdating nga diha beam, most of the stresses is distributed dida hand flanges. And maaram kita because na-prove natin ito. In fact, 91% of the moment is carried by the web. Diba? 91% of the moment is carried by the flange pala, by the flange. Tapos, more, di kita marang compare kang percentage because nag-vary man ito from case to case basis. Pero in general, most of the horizontal shearing stress is carried by the web. And most of the moment naman is carried by the flange. So kumbaga, iniya nga shape, ini nga eye shape. Prefer diya because parang na ano ba right term na
using less material.
using less material but at the same time madit ano dun maximum minimum nangalimutan the right term na nag-describe by whatever nangalimutan kan term.
Na-maximize.
Yes, na-maximize pero madit nangalimutan kan term. Okay. Na-maximize niya kumbaga it uses less material but at the same time na kuan yan na nakaka-resist siya in dako nga kuan, mas dako nga amount of bending, mas dako nga amount of horizontal shearing stress. Diba instead nga rectangle, parang nasugad, parang rectangle rectangle. Andin higing kuha, tas andi higing kuha, tas iging distribute ng kadididi. Kuha, kumbaga optimize yon, optimum. It kagamit material din is optimum. Ibig sabihin, na-maximize, na-optimize. Less material, pero mas dako an stress nga nakikarry. Ibig sabihin, mas dako an iya capacity in terms of stress. Both bending and shear. Okay? So that's it. Ito nga mas prepared din niya. Pero of course, you have also to study different types of beam. Okay? Aside from the optimum situation, may nakita gyap sinisiring the most economical section, may nakita sinisiring the most ano pa tanong sa economical section and the most efficient ba? yes, I think the most efficient section. The most efficient section. The most efficient section and the most economical section. Because then again, mabalik kita dituhan kuan naton nagde-design nga ni kita, di ba? One of the consider naton is the economy. Sabihin and resources nga gagamiton didhan yung pag-design. Okay? Without compromising the safety of your of the end user, of your stakeholders. So parang nabalik kita nga tuhan principle, ano? So anyway, I will end my discussion here. Yes. Next meeting i-discuss natin ang pagkuha naman han FB. Pag-solve han FB. Okay, i-discuss natin dito next meeting. Okay na? I hope you learned something. Sana may niyo naintindihan. Okay, sige. If you don't have any question, please open your camera. Magkuhan lang.
Sir, waray kumarigo. Char.
Same.
What's new? Joke lang. Okay, pipira kita 80 kita pero buti ulit naka-open yung camera. I-open yung camera para makita. Okay. Think ko rin na ada pag-open yung camera. Tamo pa kasi di rin naka-open. Or bangin na ako and lag rin naka-open. Anyway, so let me take the screenshot. Sorry, na airplane mode. Okay, thank you. Okay.
Sir,
Okay, thank you for listening again.
sir, excuse me, sir. May question na po ako.
Yes.
Ayan.
Yes.
Ang recording po last Sunday, mapopost po ba sa Google Class?
Yes. I'm sorry na nabibisi ako.
Oh, sige lang, sir. Pare po kasi ako makasunod last Sunday. Sige po, sir. Thank you.
Okay, okay na. Okay, thank you again, ha. Thank you for listening to my lecture, and I hope you learned something,
Evening, sir.
something new, something new. Okay, good evening.
Bye, sir.
Bye, sir.
Thank you, sir.
Thank you po. Pangaon.
Bye, sir.
Thank you, sir.
Oh,
Bye, sir. Thank you, sir.
Sir.
recording.
Bye, sir.
Thank you, sir.